Good afternoon, everybody. Thank you for being here at the end of the first day of the conference, the first full day. I know some of you are probably getting tired. I know I am because I'm still dealing with the time change and I'm wide awake at night when I should be sleeping. But I'll try to keep it interesting and get you to dinner on time. Well, my name is Al Como. My job is to worry about security for SQL Server. And I lead a team that works with all the dev teams to ensure that we build as secure a product as we can. And so today, what I'm going to be talking about is two different topics, related of course. One is a look at security features in SQL Server 2005. And some of this will be background on things that have not changed since SQL 2000 and earlier versions. And some will be focused on new capabilities in that version. So by show of hands, who here is currently using SQL 2005? A lot of you, great. So a lot of this will be background. I want to tell you that on the SQL 2005 front, I'll be drilling down in considerably more detail in a session tomorrow, which is at 10:45, DAT206, which is best practices for SQL Server 2005. I'm also going to go and jump into some of the new features in SQL 2008, some of which are in the November CTP and others which will be coming in the following CTP. Now I have a couple of interactive sessions scheduled for this week as well, one on Wednesday, one on Thursday, and the title says SQL Server 2005. But if you have any questions you want to deep drill on SQL 2008 as a result of this session, feel free to bring them to the interactive sessions. I'll be perfectly happy to entertain SQL 2008 questions. Alrighty, so let's look at some background on the SQL Server security model. This has not fundamentally changed in SQL Server 2005. So essentially, we have a model that has a scope at the server level and a scope at the database level. And at the server level, we have principles called logins. And the way you get access to the server is you present your credentials, some proof of who you are, to the server. We go through an authentication process. And you can have that credential be presented in the form of a SQL Server login, login name and a password that's provisioned inside SQL Server. It could also be a Windows user or group. All right, so there are scopes as well from a permissions perspective. Once you have presented yourself at the server level and authenticated, now you can go and take actions at the server level based on permissions that can be granted, denied, and revoked at the server level. Server level permission, for example, would be the ability to issue server level DDL. Once you've gotten to the server, if you really want to do anything of interest, you have to go and establish yourself in the context of a database. So that's the other main scope in the security model. In a database, there is a related but separate set of principles, database users. So when you enter the server, and you go in and establish yourself in the context of a database, then you can go ahead and start accessing objects within that database based on permissions you've been granted in that database. And when you connect, you always have a default database. Now, your login may have had one defined for it that's a specific user database, but if not, the default is master. That's why when you connect, even if you're not going into a database of your own to do something, you already have a database context, and you can see all the system tables and other objects that exist in the master database. One thing I should point out is one of the enabling characteristics that allows that to occur is that you have a user called guest that's in master. And so every login is by default mapped to guest. Now, guest in master is something that makes sense as a default because typically, you're not going to put your own content in master. In fact, I discourage you from doing so. And entities in master, by and large, the system tables, do have a security mechanism that's built into them. You can only see metadata for entities on which you have some permission. So it's not as if you're getting a wide open access. Guest, on the other hand, in one of your databases may not be a good idea because you may want to control who can get access to your database and always explicitly give someone a user presence in your database. Okay. The scope I mentioned before about database level permissions, if I look at database level permissions and server level permissions in aggregate in SQL Server 2005, there are about, this number may not be quite right, there are about 178 of them. which is a large increase from SQL Server 2000. The reason for the increase, we wanted you to be able to go and grant to some user just the permission that you wanted them to have, as opposed to needing, for example, to put them in some highly privileged role and perhaps conferring on them more privilege than you would like. There is a scoping mechanism. I'm actually going to drill down a little bit further detail in the slide coming up. Now you can have logins be part of server level roles, and these server level roles are built in and they have a predefined set of permissions against them, and at the server level you're not able to go and add your own custom roles. That's a feature that I'm crossing my fingers. We're still hoping to get into SQL Server 2008, the ability to create your own server roles. It's currently not officially in plan, but a few stubborn folks are really trying to get that added. So I'm crossing my fingers. That would be really great to have. At the database level, you can have users belong to database roles. So similarly, they have a set of permissions associated with them. The difference at database level is you can create your own roles and you can assign your own permissions to them, and then the management of database level permissions becomes simpler potentially, because instead of handling permissions to individuals, you can simply have a predefined role and add and remove people from that role. Let's talk about principals. The notion of a principal is really the entity who is taking some action, or on whose behalf SQL Server is taking some action. So we have principals at different levels. At the Windows level, you can present as credentials as you log in a Windows group ID, a domain or local user account. And in SQL Server, we saw logins and server roles. In a database, we saw users. What I didn't talk about in database roles, what I didn't talk about a lot was the application role. Now, the application role is an entity which is carried forward from previous versions. Starting in SQL Server 2005, I'd recommend actually moving away from application roles in favor of a login-less user. And I'm going to drill on detail on that a little bit more in this talk, but a lot more in the talk tomorrow on best practices. The motivation there is to go away from a mechanism, the application role, which has a secret that's potentially exposed, the secret being the password, and instead make use of a login-less user to accomplish the same thing, but have it be permission-based and avoid having that secret potentially exposed. We have securables. Securables are the entity on which permissions are granted. So here's where I'm going to talk about the scoping a little bit more. You can, of course, grant permission to people on things like a table. I can grant select on a table. You can also grant permissions on a containing scope. Now, tables exist inside schemas. I can grant you select permission on a schema, for example, and that gives you select permission on all the tables that currently exist and are added later to that schema. In a similar fashion, you can step back one level in the containment hierarchy and grant permissions at the database level and ultimately at the server level. So you have this ability then to decide whether you want to control permissions at a very granular level, down to a table or even a column in a table, or step back and grant permissions at a higher level scope. At the operating system level, there are securables as well in the form of Windows objects. The service, as it's installed, and the service account is granted access to all the files and register keys and other Windows entity that it needs to have access to in order to operate. So let's look a little bit more at permissions. You can grant, deny, or revoke permissions to logins or users, depending whether you're at the instance level or within a database. And you can also revoke permissions. Now, revoke is something that, for people who are more used to the Windows model, catches them somewhat by surprise, because there is no deny. There is no deny in that model. And people sometimes ask, well, why do we have a deny? It seems to complicate the model. Why can't I simply grant permissions I want someone to have and revoke them if they don't have them? Where it becomes potentially complicated is if an individual, a principal, has permission in more than one way. If, for example, I've been granted select permission directly, and also I belong to a group or role that has select permission, it would be necessary for you to go and find all the different places I hold that permission and revoke all of them. So it's easier simply to deny me select permission and on that entity, and deny always wins. Even if, therefore, I have select permission because I'm a member of a role that has select permission, If you denied me selecting that table, I cannot get to that table. Now, I want to drill down on one area that has changed in SQL Server 2005. That's the notion of user and schema separation. In prior versions, if I, as user 1, created a table, it would be called user1.tablename. Now, if it's a table that is my own private table for my use and it's not really of interest to anyone else, that model could work out fairly well. But if instead it's a table that belongs to an application, just because I'm the person who happened to create it, it's tagged user1.tablename. And now your application has to refer to it by user1.tablename. The problem is let's say that I'm a bad guy and I've embezzled from the company and you fire me. And you want to remove my access from the system. You want to remove user 1. You can't remove user 1 because there are entities that belong to the user 1. So you have a problem. For this reason, and this is not the only reason, but this is one of the reasons. For this reason, typically people will put all their objects in the DBO schema because the DBO is an account that doesn't go away. Now, there are problems with doing so. I mean, if you have a case where everything's in the DBO schema, that means if you want someone to be able to go and add, remove, or modify elements of that schema, you must make them a DBO. You must add them to the DB owner role. Here's a case where you're potentially granting them more privilege than you would like. And there are some considerations with ownership chaining, especially across database boundaries, which I'm going to elaborate on later on, but that presents an opportunity for someone to gain access to data that you may not have wanted them to gain access to. So in SQL 2005, the notion of a user and a schema was separated. And this is called for in the SQL standards. So this really is fleshing out the SQL language as supported by SQL Server. And also it's a very useful characteristic on a number of different fronts. So basically what it is I'm a user. I have a schema that's my default schema, but I may also have other schemas for which I'm the owner. So if I want to go and create a table that belongs to a payroll application, I can create a payroll or have one created for me by the DBO called payroll. And now I can go ahead and create a table in that payroll schema. It'll be called payroll.tablename. And so now my user identity is disjoint from that table identity. In fact, my role as owner of that schema is variable. My ownership can be replaced by someone else as owner. So you can change owners of schemas. So one of the things that you get then is once you've decided that this table really is a payroll table, you can code your applications to refer to payroll.tablename, and that name will remain stable, presumably, for the life of the application. And the comings and goings of whoever is responsible for the creation and maintenance of those tables, whoever is the schema owner, is not going to impact your applications. Now, I'm going to give kind of a bit of a flavor of what else is possible here, but this topic really could use up an entire session on its own. If you think then about the notion of schema as another container scope in the hierarchy, you can imagine cases then when I want to have different portions of an application be separate from each other from an administrative scope perspective and from a permissions management perspective. Whereas before you might have thrown everything all together in the DBO schema, you really can start separating them out into different elements. It doesn't mean that it's an unreasonable configuration to have a database that's dedicated just to one application where all the elements are in the DBO schema. But it does mean that it does not force you to adopt that model as it has in the past. All right, so we've covered a lot of this already. Along with the existence now of this object being a schema, there is a DDL associated with it. I can create a schema, I can alter it, I can drop it, I can change its ownership, I can go and create entities in it. So there's a full set of schema that's associated with that. And as I mentioned before, grant, deny, revoke now supports schemas as a target for the scope on which you grant those permissions. So for backward compatibility, if you have applications that already run on prior versions, you move to SQL Server 2005, you don't want the behavior to change, from a backward compatibility perspective, the default schema is named the same as the username. So if I create a user called user1 in my database, that user has as their default schema a schema called user1. That means that everything you've done in the past is going to behave in the same way. It's very easy to go and change the default schema for a user. So from a forward perspective, if I change my schema from user1, my default schema, to schema1, when I go ahead and I say create table, I don't specify a schema, it's going to go into schema1 by default. Okay, so why would you use schemas? Basically, as I mentioned, in order to give you a different encapsulation, a different administrative scope, and a different scope for managing permissions. Let's look a little bit at execution context. First, who's heard the term ownership chaining before? Okay. You may not have realized it, but prior to SQL 2005, ownership chaining was the predominant technique for encapsulating objects away from access from end users. And so here's how it worked. Let's look at a case where I have a user calling a stored procedure. In order for that call to be honored, we'll check whether that user has execute permission on that stored procedure. So they have execute permission, so far so good. That stored procedure is running, and in fact it's running in the context of that user. When that stored procedure is to make access to another object like a table, in this case it's accessing user1.t1. Here we have a case where the table is owned by a different entity than the stored procedure. In this case, normal permissions checking will happen, and since my stored procedure is still running in the context of the user, user3, that user is going to have permission to access table T1. If that permission check fails, they're not going to be able to access the table. So it's undesirable in a lot of cases to have that user have access directly to the table. Now, often the reason you have a stored procedure is to constrain what they're able to do. So alternately, you can arrange the stored procedure and a table to have the same owner. So in this case, the invocation of the stored procedure is the same. We check for execute permission. That check passes. So far, so good. As the stored procedure is running and makes reference to that table, user1.t1, there is no permission check done in that case. So myself, as the person who set up the stored procedure in the tables, I want the tables to be essentially inaccessible to the user except through the stored procedure. So this bypasses the security check. The thought is that since I wrote the stored procedure, it's my stored procedure, it's my table, I should be allowed to do what I want with the table. This is how you encapsulate access to those lower level objects away from that end user. And there's some limitations here, but not a lot of these relationships where this is supported. Essentially, from a module to a table is the majority of it, and it's not supported for a variety of different kinds of SQL. It's not supported for DDL, for example. It's supported for DML. It's not supported for dynamic DML. So, what have we done in SQL Server 2005? We have made the notion of execution context much more explicit. So if we look at the example we have here, we've modified the way in which you define a stored procedure to optionally specify what context the stored procedure runs as. So let's look at this stored procedure that's marked to execute as X. I'm still user 3. I still will make my request to execute that stored procedure. I must pass the test that says, do I have execute privilege on that stored procedure? So I have the permission, the check passes, the stored procedure begins executing. In this case, though, it's not executing as me. It's executing as this user X. So now when the stored procedure makes access to some other entity, in this case user1.t1, we will make a check for the current execution context, in this case X. If the check passes, then it'll proceed. So this provides an explicit way in which to control the current execution context and do encapsulation. So what's special about this as compared to what you were able to do in the past? Well, first thing is that the execution context is honored for all operations. It doesn't matter whether it's a stored procedure, as we've done here. There's also a standalone statement that you can execute at any time saying execute as and give some login or some user, depending whether you're executing at the server scope or the database scope. So you can issue that statement anytime and change your execution context. And that execution context now becomes who you're running as. Your SQL Server security token has that as who you are. You can in fact stack these to any arbitrary depth. So if I call a stored procedure that executes as X, and it calls a stored procedure that executes as Y, on my execution context stack, I have my original context, then I have X, and I have Y. And there are controlled ways in which you can revert back. We always honor module boundaries. So stored procedure as a module, if I was to have user 3, as in this case, call the stored procedure and have the stored procedure try to do a revert back to user 3, it can't do that. That other context is on the other side of a module boundary, and that revert will not happen. So what this allows you to do then is to write reusable libraries of stored procedures where you don't have to worry about who has called you and what context that they're running in, who you're calling and what they might try to do maliciously, for example, in terms of reverting and trying to regain your context. You can write standalone reusable stored procedures. Now there's a lot more I can go into in this topic, but I'm going to save that for the best practices tomorrow. Now, a lot of these things we're going to have already covered on the slide deck, so I'll just see if we have something that we've not covered yet. No ownership chaining. For dynamic SQL as well, as I mentioned, any operation you do is in the context. It really is an impersonation. So think about it that way. It really changes your context, and everything you do is now in that context. Now let's look at the various flavors of execute as you can specify on a stored procedure. Execute as caller, although there was no syntax for it, was the default in past versions. It's actually a very good default. If you think about what an attacker might try to do in terms of trying to compromise your stored procedure, for example, they might try to inject SQL through your parameters, depending on what the stored procedure does and whether it's susceptible to SQL injection. If you have a stored procedure that's specified to execute as caller, when I call the stored procedure, it's running as me. Even if I can find some way to subvert it and have it run SQL of my choosing, it's running as me. So it can't do anything that I can't already do. In other words, there's no elevation of privilege opportunity. So as a default, that's a very good and secure behavior. And that continues to remain the default so that you have backward compatibility. I can say execute as some user. And I specify that user specifically, and that definition becomes part of the definition of the stored procedure. So here you need to be careful if you're going to use this, that you need to be sure that your stored procedure cannot be subverted by a malicious input. You know, if for example, you are accepting values from the caller that you're going to plug into a SQL statement, try to use parameterized SQL if possible. The language does not allow for everything to be parameterized. Sometimes you will need to go ahead and do some string concatenations to build a SQL statement. Make sure you escape any of the input that you're concatenating using the quote name function. So the key point here is that if you're having the stored procedure running as a specific context, and it's possible that context has more privilege than the caller, which is likely, you need to be more careful about ensuring that your stored procedure is not susceptible to being compromised. There are other couple of variations. The first two are really the key ones. The next one is execute as self. This is a shorthand to say execute as whoever is currently issuing the create procedure statement. And self resolves to that person at that point and captures that identity. And why would you have this? Imagine that you have a tool or a scripting that you're allowing someone else to call to create stored procedures, as opposed to having to get their identity and then go and add it to your create proc statement. Execute as self basically has it execute as them. So it's really a shorthand, it's convenience. And the last one is execute as owner. If you decide that you'd like to have this stored procedure always execute as the owner, no matter whom the owner is, and even if the owner changes in the future, and you specify execute as owner and you'll get that behavior. So why would you use execute as? You may already be using set user. There's some shortcomings of set user. First, you need to have a high privilege level in order to execute set user. The other thing is that you can't stack multiple execution contexts. Once you have a current execution context and you move over to a new one using set user, if you issue set user again, you will get what I'll have to refer to as somewhat non-deterministic behavior. There is a description of that behavior, but it's so complex that it's really not reasonable for us to expect anyone to understand it. The other thing is that the notion of reverting from a set user may also get you into some difficulty. And one of the things that was a convergence between this set user functionality and another new SQL Server 2005 functionality, that was the multiple active result sets. The notion that I can have, from one client, multiple independent connections at the same time. So you get to a lot of trouble with set user in terms of I do set user on one of these connections and I do revert on another connection. Now, that behavior definitely is non-deterministic. Whereas when it comes to the formalized execution context support we've added with the proper stacking, we do deal with those situations. The last thing is interesting. I mentioned before there were 178 permissions that we added, and the motivation was to make sure that if you needed to go and enable someone to do a specific task, hopefully you can find a permission that's suitable. But there's really no way that we're able to go and anticipate all those situations. So you can use execute as a means to build your own custom permission sets. Now there's an example in Books Online, which I'll use here. It's allowing someone to truncate a table without granting them alter privilege on that table. Alter privilege on a table lets you do a number of different things to modify the schema of that table, and you may not want to give someone that permission. And since we didn't add a truncate table permission, what you can do as the owner of the table is write a stored procedure, have that stored procedure execute as you, and then have that stored procedure go ahead and truncate your table. And now what you can do is grant anyone you like execute permission on that stored procedure, and they're able to now go ahead and truncate your table, but you've not granted them alter privilege. So you can take this idea and you can imagine any number of different types of custom permission sets that you can create for yourself. That being said, if there is a native permission that you think would be very useful to have in the product, please let us know, because based on that demand, we'll go ahead and add additional permissions. We have 178 already. We're not shy about adding more. I'm going to touch base a little bit here on another concept as well, and it has to do with a specifying trust at a database level. But first, some background as to why this mechanism was created and why it's relevant. Remember the ownership chaining I described earlier. I have a stored procedure owned by user one, referencing a table owned by user one. There's no permission check, right? That's an encapsulation technique. It's a very useful and powerful technique. However, based on the number of hands who had not heard of that technique and maybe not aware they're using it, are likely not aware that ownership chaining also crossed database boundaries. So it's possible then, if I have a stored procedure in one database, that it can make reference to a table in another database as long as the owners are the same. So that brings up the question, what does it mean for a stored procedure in one database to have the same owner as a table in another database? When you are doing this mapping across database boundaries, you always bounce back up to the server level. So the user that you are in this database maps back to a login at the server level. The login maps to a user at the database level. If these two objects map to the same login, they have the same owner. So this is by design for ownership chaining, but we were concerned that people may not realize this was the behavior that they get by having, in this case, for example, databases owned by the same DBO. In fact, if you think of a scenario where the sysadmin creates all your databases, right? The sysadmin is the DBO of all databases. All those databases, excuse me, are owned by the same user. And then any objects in the DBO schema are subject to ownership chaining. So here's one of the reasons why DBO schema can be undesirable. I have DBO.storedProcedure1 referring over here to DBO.T1, and DBOs both are sysadmin, so they map to the same login. I can ownership chain across that. So for that reason, starting in SQL Server 2000 SP3, we turned off ownership chaining across databases. In fact, it's a setting that we've called CDOC, which stands for Cross Database Ownership Chaining, and it's off. You can turn it back on. I would recommend you don't do so. You can turn it back on at the server level, you can turn it back on at individual database level. If you do need to have a case where you want selected trust across database boundaries, here's one of the techniques that you would use. So imagine you have this login coming in, and I want to have database 2 be able to reference objects in database 1. Now, database 2 and database 1 have to establish a trust relationship. So you want the DBOs in each database to take some explicit act to say, I want this trust to exist. So what happens is, in database 2, I grant a permission, in this case the authenticate permission, to the owner of database 1. That's basically saying database 2 trusts the owner of database 1. Now, what I want to point out here is that what you're really doing is you're not trusting database 1, you're trusting the owner of database 1. So that particular DBO may in fact own a number of different databases. And you may not want to have this trust relationship across all of those databases. So you're trusting that person, you may want to trust all the databases. So what the owner of database 1 can do then is set the trustworthy bit on for database 1, which is basically saying, for those who trust me, I only want them to trust database 1. So the user owning database 1 may not want to have the ability for their other databases to have this relationship. So there is, oops, I thought there was another, okay. I thought there was another piece coming up in this animation. So this trustworthy bit is not actually a means of opening up a database to additional trust. It's actually a means of constraining it. A means of saying that even though I, as a DBO, am trusted by this other person, I'm going to constrain that just to this one database I own. So this is a fairly coarse trust relationship. It's not as coarse as CDOC, in which case all databases owned by the same user have an inherent trust relationship. It's still a database level trust relationship. Now there's another trust technique, which I'm not going to go into here, which I will drill on a little bit more tomorrow, that is much more granular, where you can have a module in one database, for example, a stored procedure, signed by a particular certificate, and have the other database trust that certificate. And you're then able to really constrain that trust down just to, if you like, running this one stored procedure. You can control exactly what can be done and by whom. You can, for example, have the stored procedure constrained to only perform certain operations. So that's a very low level of cross-database trust. So, summary then, cross-database ownership chaining was too wide open. It was turned off in SQL Server 2000 and SP3. Do not turn it back on unless you really believe that you need it. And we have alternate methods to establish cross-database trust, starting in SQL Server 2005. Okay. Why would you use cross-database ownership chaining? As I mentioned, for establishing this trust at a very low level. A real-world example that I like to use is, imagine that you have someone created one business application, human resources application that has a database, it has a set of stored procedures, it has the application code, and that is being used and it's adding value to the business. So that's HR. You have someone else who's created a payroll application that's separate, it has its own database, it has its own stored procedures, its own data, it has its own application. It's certainly not hard to imagine a case where someone says, I can think of a third business application that actually combines elements of both of them. And so now you have this case for this application needing to go and access content from one database and content from the other database. So you may actually have a need to have this cross-database trust established. So rather than having to throw away your two existing applications, your two existing databases, and invent a new third one that serves all three needs, you can actually start opening up selective trust across the database boundaries and achieve the same goal. So, as I mentioned, trustworthy bit is actually there to constrain access, so it's not, as some people have thought, a dangerous or insecure operation. Let's look at data encryption. So why consider encryption? Well, you see a lot of press about companies that lose data, and they lose it in a public manner. They are subject to various regulations, they get sued, they get lawsuits, they have findings against them. It's really not something you'd like to do. And encryption is really gaining acceptance as a key way to stop those kinds of disclosures. And encryption basically, from a philosophical perspective, comes in two flavors. Encryption of data at rest and encryption of data in motion. And data in motion is as you're sending them across the wire, for example, to have your communications channel encrypted. That's data in motion. Data at rest is more concerned about someone getting physical access to the media on which the data is stored, whether they get access to your machine as it's live and serving its purpose, or whether they get access to a backup image which has been left insecure. So here from data encryption, I'm really talking about the first flavor, which is encryption of data at rest. So the history of encryption in SQL Server is in SQL Server 2000, there was no native encryption. You had to buy it from a third-party vendor. Starting in SQL Server 2005, we added built-in data encryption, give you a very fine, granular control over what's encrypted, but required that you change your application. Along with this encryption capability came a key hierarchy and the ability to manage those keys. So if we look at what this application might need to do, here I have a case where I have a table, and I'll draw your attention to the update at the bottom. I have this update occurring where I'm setting some column to some value, and I want the value to be protected. So I'm calling this function encrypt by key. And in there I'm passing the GUID of a key, which I have previously created. And in fact, you look higher up in that sequence of code where I've opened the key. So here is a somewhat of a more advanced, if you like, notion of encrypting data at rest. Typically what happens when you have an encryption solution for data at rest, it's applied at the media level, and as soon as the data is read off the media, it's decrypted. And from that point forward, all you need to do is pass the usual authorization check, and you'll be served up that data in the clear. Here's an additional demand, which is you have to also have the key. So the key hierarchy, which I'm going to expand on in I think the next slide, excuse me, the key hierarchy lets you then have a granular level of control over who has access to what keys. And if you can't open the key and put it on your session local key ring, you can't decrypt that data. This is where the granularity comes in. I can have in one table, in one column, in a specific row of that table, that value encrypted by a key different than the key used to encrypt other values in that same column. So you have a very fine granularity of control. This is what we refer to as cell-level encryption. But as I mentioned, this comes at a cost, which is you have to change the application. Let's look at more detail. We have the notion then of having some keys and needing to manage them. And we have the ability to go ahead and create keys that are symmetric keys, create keys that are asymmetric keys, and create what we call certificates. Now, the use of the term certificates here has caused some degree of confusion, so let me elaborate on that. We refer to a certificate really as a container for a private key, public key pair. Now, it can be derived from a real certificate. You can pass in a real X509 certificate on the create certificate statement and give those to SQL Server and say, I want SQL Server to provision this private key and public key for my usage within SQL Server. That does make a disjoint from the certificate and from the certificate store on Windows. And the primary motivation for doing that is now these certificates are part of your SQL installation, and it allows you to manage them more easily in terms of database backup and restore and attach detach scenarios, and recovery, and especially remote offsite recovery scenarios. Part of what we have done in SQL Server 2008 actually builds on the story and lets you plug into the broader set of keys and certificates that are in your environment. But let's get to that when we get to that. As far as the keys themselves, there's a hierarchy which I'm going to go to, but essentially you have keys protecting keys protecting keys. And you have a wide variety of algorithms you can choose from, essentially everything that was supported by Windows at the time we shipped. SQL Server does not have any cryptographic code. We call into the Windows cryptographic service provider. So let's look at that in more detail. Ultimately, we use Windows as the root of trust for our key hierarchy. We call into the Data Protection API, DP API, in order to have it go and encrypt based on a key that it has care and control of that we don't have access to. We will use DP API to go and encrypt a key that we have at the instance level or the service level. We call that the service master key. In turn, if you want to go and use encryption capabilities at a database, you don't get a database master key by default, but you can create one. This is the key that routes all the encryption occurring in that database. And that isolation is important because once I have the database master key, I can take that database, back it up, and restore it, and still have it be decryptable in this target location. But the database master key has to be protected. So it's protected by default by the service master key, and you can go and add additional encryptions of your choosing using, for example, a password. So why a password in this case? The password makes it portable. If I have a database in which I have encryption rooted at the database master key, and I want to take that database elsewhere, I can go add encryption using a password, suitably long and strong one. I can remove the encryption, which is the encryption from the service master key, and I can take that database elsewhere. As long as when I bring it to the target location and I do an attach, as long as I have also passed along the passphrase out of band here, so it's not all traveling together, I can use the passphrase to decrypt and re-encrypt the database master key in its destination. So the database master key is important in terms of being able to give that portability. So in turn, you can have the database master key be used to encrypt certificates and asymmetric keys in your installation. You can choose to actually have additional encryptions of using passwords on these if you like. Ultimately, you'd like to get down to a symmetric key, which is then used to go and encrypt your table data. Now here I show both a asymmetric key insert and a symmetric key being used to encrypt table data. Both can be done. But encryption and decryption using a symmetric key is much faster than using an asymmetric key or a certificate. So typically what you'll do is you will encrypt the data using a symmetric key. That'll be protected in turn by an asymmetric key or certificate, which will be protected in turn by the database master key. What's interesting to note is that you can do key rotation in most of these levels without there being a significant performance hit. I can, for example, take my symmetric key and add an encryption with a new key and remove the old key, and I've not touched any of the data. If you believe that your symmetric key has somehow been compromised, however, and you have to go and change the symmetric key itself, that can be done using DDL, but we'll have to go and decrypt and re-encrypt all the data, which can be a very lengthy operation. There we go. Finally, you can actually have a password being used at the data level as well. And so whenever you have a password, it's a secret that's not held by the DBO or by the sysadmin. That's a secret that you have. And you can use that to prevent the DBO or sysadmin from accessing that data. Now, passphrase is a little bit awkward to use, so we'll look at SQL 2008 and how we made that story better. But you do have the ability to have a secret that's out of band of the administrators that you can use to protect data that only you have the key for. So service master key, as I mentioned, is at the server level. It's used to encrypt a number of server level entities directly, link server passwords, database master keys, and proxy credentials. You may have heard of the credential store. That's where you can store a set of credentials in SQL Server for use by things such as SQL agent jobs. And, these are typically Windows credentials, and so you want to be very careful on how they're protected, and they're actually encrypted using the service master key. It's important to understand that you have a responsibility to make sure that you always have these keys when you need them. So if you have a database master key, which is in the database on disk, if you lose that media, you'll lose that database master key unless you've backed it up, and you can back up the database master key. Similarly, you can back up the service master key. You can also use these backed up images to go ahead and restore them on some other server where you want to have those same keys provisioned if you want to use that server, for example, for disaster recovery. So it's important to back up these keys, and these backup files can also be used to provision the keys on other systems. Database master key we basically touched on as well, secures all the keys inside the database and gives you that notion of portability of that database. So that's the summary of security features in SQL Server 2005. There's a number I haven't really touched on, and as I mentioned before, if you want to see more, please come to the talk tomorrow at 10:45 on SQL Server 2005 best practices. Okay, let's jump into SQL Server 2008. Let's look at protecting data. In SQL Server 2005, we saw that to encrypt, we have to use built-in encryption functions. You could also encrypt your databases using EFS. EFS actually is a great solution. I use it on all my systems to protect data that I don't want compromised. There's a problem though, and try to use it in a high-performance database system. EFS does not do data prefetch. So if you have a highly I/O-intensive scenario, EFS is not going to perform well for you. You can use BitLocker if you have Vista and upcoming Windows Server 2008. Many people probably don't realize this, but BitLocker is designed as a means of protecting the vulnerability window that exists during the boot sequence of the machine in the operating system. EFS, for example, starts operating once the machine is up and running, Windows is up and running, and can go ahead and start executing. BitLocker was there as a means to protect the drive on which the OS lives and starts to run very closely after the BIOS stops running. And it's there to really constrain that window, which is why, by the way, it's designed to support only one volume, because it's meant as an adjunct to EFS. Because it's turned out to be a very popular feature, Windows Server 2008, I believe, has made it such that you can support multiple drives being BitLocker encrypted. Great for a multi-disk system, probably not relevant on your laptop because you almost likely have only one disk and can use BitLocker as a reasonable solution there. And finally, you can use Windows integrated authentication as a way of making sure that your data is accessible only by highly trusted and validated users. So what about SQL Server 2008? There's a few different things I want to talk about. One is extensible key management. And I'm going to elaborate on each of these in a number of slides, and I have some demos as well. This essentially lets you plug into a broader scheme for doing key management and for doing offloading encryption. There's the transparent data encryption, which is the true traditional data at rest encryption, where data as it's served off disk will be decrypted. There's some enhancements to integrated authentication meant to deal with bringing up the different protocols to the same level and also to address potential NTLM downgrade attacks. All right, so let's look at extensible key management. This is a feature that lets you call out to a provider that does key management in a centralized device, or depending on the vendor you're calling out to, sometimes it's done on an agent on the same machine. Essentially lets you offload your key management and not have to use the built-in SQL Server key management, but instead use the same key management that you're using across the enterprise. So the philosophy here is we did not want to build a custom SQL Server solution for doing key management, because in the real world, key management is a problem that's scoped beyond just the database. So for the providers then that are supporting this integration model, you can call out to them to do key management, to do key rotation, to do key escrow, to do key retiring, You can call out to them, depending on the provider, what they're able to do, to offload encryption to them, either to software-based encryption, to hardware-based encryption. So it's essentially a programming model that lets you call out and take advantage of the set of features that a variety of these vendors support. Reasons to use it. As I mentioned before, here's a way of actually having a holistic approach to key management across all the different key usages in your enterprise. No more SQL Server only solution. Now the built-in key hierarchy and the management we have is still useful. Not everyone has a large enterprise and has an external key management capability, but in terms of that larger scope, this is the solution we believe is better to serve your needs. If you look at things like who can access the keys, and I noticed that in the polishing of these slides, some of the text has slid down a little bit, but imagine the case, as we saw earlier, where you want to have a secret that is not accessible to the DBO or sysadmin. But you have a passphrase today, which is awkward. You have to have some way of keeping the passphrase safely off to the side, providing it when needed. Why not instead have a key in a USB device? Something you can do now when you're plugged into these providers. So imagine a case where it's your data, and you don't want the administrators to get to it. You have your USB device. When it's time to go ahead and access your data, you plug in your USB device. There's your key. You can access your data. The other administrators cannot. So great for things like separation of duties. One of the things as well is if you do integrate with a vendor that actually has a hardware encryption device, you can offload the encryption to that hardware, and you can address any perfit that you're experiencing in terms of running encryption on your system. Now note that this is actually fairly significant from an architectural perspective. We're not simply now always calling into the Windows cryptographic service provider. We're calling out to some other third-party cryptographic service provider. So now it's really a wide open world. So I don't have a demo for EKM. It's actually difficult to demo without having partners. EKM is in the November CTP. I'm not aware whether any of the partners that are currently on board are yet willing to divulge themselves. If and when they do, then you can actually go ahead and sync up with those vendors and their own CTPs and try this out. So there's really not a whole lot I can demo there. Let's look at the next one, transparent data encryption. This is in the November CTP. We'll have a demo of it coming up shortly. It really is the traditional encryption of data at rest. You can turn on encryption for the database, and all the database files, the data files, log files, everything are encrypted as they reside on disk. The decryption occurs implicitly as pages are loaded off the disk and brought into our buffer pool. Now from that point forward to the rest of the SQL engine, it looks exactly the same as a non-encrypted database. That lets you avoid a lot of the difficulties you get into when you're trying to have encryption at a smaller granularity. Now, for example, if you encrypt a column, then any operations that you perform that where the value of the column has a semantic meaning, those operations are broken. The traditional one that people worry about is indexing. Now you can get a special case where if you're indexing simply to do a singleton lookup and just retrieve one row, you can work around that. If you have things like constraints or anything other that's value-based, then you're going to discover that encrypting the column simply doesn't work. It breaks your applications. Now, you can't do things like range predicates, for example, in a performant manner, because with the base columns of the values of the column may be two values that are close together and the range is quite small. When they're encrypted, they're randomized, and the optimizer is going to say, well, these two values are actually quite far apart. Therefore, either the range predicate is too non-selective, I'm not going to use it, I'm going to use a table scan instead, or we'll use a very expensive range predicate. So the bottom line is to really get an application to behave well with column level encryption, you have to design the schema in advance with the notion of encrypting the column, and you have to go ahead and design your queries with that notion as well. So it's transparent after you've done all the work to make it transparent. So here we have the other extreme, which says, let's make it very simple and easy. Let's just check a box, which is not quite that simple, but we'll get to that, and say that this database is encrypted. And in the background, the encryption occurs, and from that point forward, the database remains encrypted. And so there's a number of things that this solution has that are desirable. One is a property I called stickiness. It doesn't matter where that database goes. If you take it from this disk on this machine and put it on that disk on that machine, if you're depending on disk level encryption, the target machine may not have the disk encrypted. You don't know. The database will always have that property to be encrypted no matter how and where you transport it. The other thing as well is that the fact that it's encrypted is known within SQL Server. So you can actually do things like take advantage of another feature in SQL 2008, the Declarative Management Framework, and specify policies based on databases being encrypted. For example, if a database is encrypted, you might want to have additional conditions that say this database must not allow SQL logins, for example, or this database must have a backup plan, or this database, it's whatever you like. Once you have that knowledge that the database is encrypted, you can actually have automated policies that respect and react to that setting. Now, if we see here, we have the notion of a database encryption key, which is stored in the database, so it has that notion of being transportable as well, but it also has to be protected. So you can protect it using a password, we can protect it using the service master key, and you can go ahead and, if you're integrating with an external hardware security module or external key provider, you can go ahead and have that hardware security module also protect the data encryption key. Now I have to call out that that last bit, the hardware security module, the encryption, or sorry, the integration with the external HSM provider, that's not part of the November CTP. That'll be part of the CTP that follows, but everything else is there. Now, if you're going to take this database and remove it from its current installation and bring it elsewhere and try to attach it, first of all, it's encrypted, so you're not going to have a disclosure, but you can't even attach it if the target destination doesn't have the key. So I think, so some scenarios here. I mean, it's pretty clear that things like lost laptop scenarios are a key target for this. Anyone who gets access to your backup images. If you have a database that's encrypted and you back it up, you're backing up the encrypted image. It's not decrypted on the fly. So if you do actually want to have it decrypted because you're taking it elsewhere in your process and you want to deal with encryption on backup media, you actually have to decrypt it in order to do that. All right, so I think this is where we have our first demo. And my machine seems to have gone to sleep. So let's see if we can wake it up. All right, press the magic button. There we go. All right. Here I have an instance of SQL Server running. I haven't provisioned anything yet, so we're starting right from the start. Let me go ahead and create a database that I'm going to use. Let me connect first. All right, and let's go ahead and start using that database. Let's go ahead and give ourselves some test data. So let's create a table. And see that we have data in that table, and it's data that we're consider sensitive because Social Security numbers for Bill Gates and Steve Ballmer, they probably don't want anyone to know what that is. All right, so let's go back to our master database and let's do some provisioning that's going to allow us to support this encryption. So your master database. First, as I mentioned earlier, you don't get a database master key automatically. You have to go and create one. So I'm going to want to do some encryption here of some keys in master database. So I'm going to go ahead and create a master key in master database, a database master key. And here I'm creating a certificate which will be used to protect my data encryption key in the database. As I mentioned before, backups are good. So first thing I'm going to do is back up my certificate. And it's created a certificate in a file, which is actually here. And it's also created an additional file that contains the private key on which I have an encryption on that file specifically. You don't want the private key to be compromised, so the private key is traveling encrypted, and it has a password that's enforcing that encryption. I can take this backup file, I can bring it to another machine, and I can go ahead and do a restore there. Now I have my certificate replicated on that other machine. All right, let's go back to the database that we want to go ahead and encrypt. So we're now in our database. I have to create the key that's going to be used to encrypt this database. And that's the database encryption key. I'm creating here one that is using the AES with a 128-bit key. And I'm specifying the certificate I just created as the key used to protect my database encryption key. So we're almost there. I've now gone and provisioned all the key material that I need to do the encryption. Now it's simply a matter of altering the database and setting the encryption property on. So let's look at this DMV for database encryption keys. Database 5 is a database I just encrypted, and it has there all the information about the key and when it was created. But surprise, I actually have two databases encrypted. Does anyone know what database 2 is? TempDB. Since you have a database that's encrypted, and some of the content may bleed into TempDB, we've encrypted TempDB implicitly. And TempDB has a database encryption key that's protected by the service master key, and it's actually recreated on every server startup. In fact, every time the server starts, we'll go ahead, we'll look to see if there are any encrypted databases, and if there are, we'll go ahead and have the TempDB encrypted. The question?
Yes, this particular behavior may be affecting in a bad way a single server because it can be shared among different databases.
Right.
So this could be a performance.
Right.
Can you talk about that?
Yeah, so the comment is that this may impact performance of other usage of TempDB, and that's true. TempDB, in a lot of cases, is going to stay in memory, so it's really not an issue because unless you go to disk, there's no encryption. But you may have a TempDB usage that requires you to go to disk. In the November CTP, the encryption applies to all of TempDB. There's work going on for the CTP that follows to have that apply only to the pages that actually belong to the encrypted database. All right. Let's go ahead and select our data. From the behavior of the system, you can't tell that it's encrypted. It's actually the same as you would get if you EFS encrypt files on your server. On your laptop, for example, you just use it as normal. You don't even know what's going on. So since we did this in code, let's also look at Object Explorer, because we have some properties here. So we look at my databases. There is my sensitive data. That's the name of the database I created, which I just encrypted. And I can go look at its properties. There we go. I look at options, and I can see here that I have this encryption enabled value, which is currently true, and I can change that back to false from here from the tool. Now, as you go ahead and where did that go? Oh, I'm sorry. Yes, I missed that point over here. Let's go and look at this again. If you have a database that contains a lot of data and you turn on encryption, we will start a background task. We'll start encrypting the data. And so you need to pay attention to this encryption state. Right now the encryption state is 3. 3 means that the database is fully encrypted. I may have the state be 1, which means it's not encrypted. So I have a database encryption key that exists, but the database is not encrypted. The state to look out for is if you go ahead, you turn on encryption, it's going to go into state 2. Which is it's currently encrypting the database. While this is happening, you'll have a mix of some data that's encrypted and some that's not. So don't expose that data to potential loss until the state goes to 3 and you've gone to a state where it's completely encrypted. Some of the other states, for example, are key change. I can go ahead and change the key. And in doing so, we start a background task again that will decrypt from the old key and encrypt using the new key. And both keys will be part of this definition until that completes. So you'll have a key change status as well that you'll need to pay attention to. Data is actually not exposed in that scenario because the data is either encrypted with the old key or the new key. But if you have this transitional stage, and you have a failure and you want to bring this database to another machine and do a restore for disaster recovery, you'll need to have both those keys over there to be able to continue the key change. And finally, the last state is that it's being decrypted. And if you decide to turn off encryption and you want to go ahead and handle the media in the clear, for example, you need to wait for the decryption to complete so that the files are in the clear. There's a question back. Metrics as in terms of performance benchmarks? Yes, very good question. So look at what is going on here. We have a background task, if you like. We have I/O going on where that today is reading data off the disk and bringing it to the buffer pool. So we're taking that path length and we're adding some encryption cost or some additional CPU cost. So that path length is distinct from the query path length. So we've run a number of different measurements and different benchmarks that have shown typically 3 to 5% degradation as a result of doing this. And that basically does take advantage of the fact that we have the I/O threads that are being impacted and the query threads are not. Now, that's not going to be the worst case. You can imagine a scenario where you have data that's being brought into the buffer pool and flushed out quickly because of a lot of large scans going on. And you can imagine then that every time you want to go reference data, it's not already resident in the buffer in the clear, it needs to be decrypted. And if that workload, worst case, is one that is keeping the CPU very busy, in other words, it's not I/O bound, then that's going to be the worst case possible. Such a scenario typically will be I/O bound, so the worst case may not be as bad as it looks. That being said, if you find yourself in that case, then by adding more memory, making the buffer pool larger, then you could potentially alleviate that. But we believe that in the majority of usage scenarios, you can expect a reasonably modest perf hit. Now, we are very interested in having your experience either validate or not that's actually the case. So I would encourage you to take the CTP once it comes out and give it a try and let us know what you get. Yes, question? The question is? Yes. Right, so the property to turn encryption off, I can issue the same alter statement here and use off, or I can go ahead and go from Management Studio and just turn that property to false. Pardon me?
So the data is not encrypted.
Right, if you turn the property off, the data will go ahead and start decrypting the data, and once the decryption ends, the data will be in the clear.
So maybe ask
I'm sorry?
deny the data asked to turn it off.
Right, so the DBO is able to turn it off if they choose. Right, there's no way to stop them from turning it off. Okay, so that's the demo for the transparent data encryption. Any more questions before we move on? Yes. I'm sorry? Yes. So the comment is whether this is integrated with the Microsoft certificate server. The integration here will be with the external provider for the HSM or the EKM. All right. We have some integrated authentication enhancements. In SQL Server 2005, if you want to use Kerberos as an authentication protocol, that was only available using TCP/IP, and you had to register an SPN with the Active Directory. In SQL Server 2008, you are not restricted now just to TCP/IP. All of our providers support Kerberos. Further, you can specify the SPN on your connection string. You don't have to have it provisioned in Active Directory. You don't have to worry about having resolution of ports through a SQL browser, for example. All right, so why? Is that a question? Oh, go back. Yes, and I'm going to drill down in more detail. Basically, you can provide the SPN on your connection string. So why specify an SPN in the connection? If you look at how the SPN typically is resolved, you have to go out to the DNS server. And I'm not sure how much you keep up on this, but there's a lot of DNS server attacks that go on in the world. And therefore, the DNS server and information returns to you is potentially untrusted. Similarly, if you go and resolve the port number, for example, with the SQL browser, that's an unauthenticated protocol. A man in the middle can feed you incorrect information. So you're subject to a number of attacks in terms of having yourself routed to a rogue server. You're subject to attacks that have the request for Kerberos be downgraded to an NTLM, and you don't get that mutual authentication anymore, and you may not be able to authenticate that the server that you're connecting to is in fact the server that you intended. All right. Any more questions on? All right, let's go on the last topic then, on detecting data misuse and privacy. SQL Server 2005 has a number of means by which one can do audit. Now, we didn't call it audit. We've done a clever job of hiding the audit capabilities from people. Fundamentally, the audit is based off of instrumentation sprinkled through the engine, thousands of instrumentation points that will record the occurrence of anything that's considered an interesting operation. And the primary means by which this is exposed is SQL Trace. Now, SQL Trace is used for not only capturing things from a security relevant perspective, it's used for doing things like problem diagnosis, it's used for doing things like performance analysis and so on. So there's no real audit flavor to it, but if you go ahead and you open up the profiler, which is the UI tool, you will see as you navigate down the left panel, you'll have a node for security. You expand it, gives you a lot of different choices of what you can audit and a lot of different pieces of information you can choose to include in each audit record. So fundamentally, audit had a complete set of instrumentation in SQL Server 2005, just not necessarily as readily accessible as we would like. You could also use DDL and DML triggers to capture events when those occur. And finally, third-party tools that will both use SQL Trace and DDL and DML, and sometimes they will actually go ahead and read the transaction log. It was difficult to use for a variety of reasons. One is the tool support was not great, and the other thing is really outside of the server engine. So, SQL Server 2008, a feature called All Action Audit, a name which has a particular motivation early on, which really doesn't apply anymore, but it's the name we carry forward, so it really is, here's the cool new audit for SQL Server 2008. What's different about it? Well, first, it's actually called audit, which is a big step forward. The second thing is that you actually define audit objects within the schema of your database and within the schema of your server instance. So if I have a database and I have a number of things I'd like to audit, I can go create an audit specification in the database. It's a proper first-class database object. It has DDL statements, definitions recorded in the system table. It has a permissions model. It has all those things you get with a first-class object. And it's part of the database. If you back up, restore, attach, detach, whatever that database, that definition stays with it. Unlike if you had SQL Trace, for example, you had a SQL Trace file, it's a file sitting off in the file system. It's very easy for these things to get lost. There's a parity with SQL Server 2005 audit generation. By that I mean the statement I made earlier that there was instrumentation everywhere in SQL Server 2005. The same degree of selectivity exists here. You have, though, something you didn't have with SQL Trace is some control over the granularity. If you were using Profiler and you turned on instrumentation points in SQL Server 2005 and you had a bunch of audit records gathered and you're only interested in audit actions by a certain user, you could do that, but the audit trail was created in its entirety, and then after the fact you went and you filtered out from the audit trail. Here, the new version of the instrumentation lets you filter out at the source. So at the database, you can say, I want to audit for this table and for this user, for example. So you can specify objects, you can specify users. From a performance perspective, if you have a subset of actions you're interested in, you could actually get a much lower cost of the audit generation as compared to using SQL Trace. So we're running a little bit short of time. So let me go ahead and get to the demo. Let's get this other demo out of the way. So for here, I'm going to create a database call audit DB. And I'm going to create a couple of logins I'm going to use here. And I'm going to go into the audit DB and I'm going to create users related to those logins. Let's get ourselves some tables created. There's one table. There's a second table. Let's populate them with data. So there's a table with sensitive user information, and here's another showing some transaction information. All right. Let's also grant privileges to our users within that database. So let's set up some auditing. Let's go back to the master database. And the first thing I'm going to do is create what's called a server audit. It's a server level entity, and it basically captures properties and settings related to where you want the audit to go. So in this example, I'm creating an audit that's going to go to a particular file. All right. If I look at the place where I've specified this to go, the file's actually not there yet because I've not enabled audit. I would like to also audit certain activities that occur broadly across the entire server. So I'm going to create a server level audit specification, i.e. here's a object that defines what I want to audit. And you can create as many of these as you like, and they're named, and you can start and stop them as you like. So I have a server level audit specification that is added to the failed login group, successful login group, and the logout group. Now let's go ahead and do something at the database level. Database level, I want to do a little more selective audit. I want to select on this table by everyone. And I want to audit insert on this table only by the user called lowpriv. All right. So I have my audit definitions all in place. Let's go back to master. And now we will turn on the server audit. We'll turn on that audit destination. Having done so, I go back to my location on disk and I see I have a file created. Every time I turn on the audit, I'll get a new file started if I'm using file. When I turn off the audit, I will get that file will be closed. And then over time, if you turn it on and off, you'll gather a set of audit files. Let's look inside that file. We have this built-in function, fn get audit file, which will show us what's going on so far. And there's only one entry so far, and it says basically the audit has started. So let's do some activities. This guy is connected, so let's go to the audit database and do an insert into that table. That's an insert where some auditing is being done, but not for this user. So if I go back and look again, I've seen that I have a successful login. LGI is login success, but I don't have any actual activity for that table. Go back, and I will go ahead and issue this select, right? This is a table we're auditing public. So if I go back again, then I will see, in fact, I think I've already run over time, so I might be in trouble. I will see that I have the audit entry there for that one. So the rest of the demo basically is showing a number of different operations by the low priv user and high priv user, which basically will show the entry showing up in the audit trail. What I want to call out here is that you can do this all from Management Studio as well. If I go to the server level and I go to the security node, I have my audit test here. That's my audit destination. And here you can see that I have the name, I have a ability to have a queue delay. It's basically a performance enhancement for being able to go and queue up results and not have every single one be a synchronous write to the file. I can click this button here which says shut down server on audit log failure. If we're ever unable to audit to the destination, you can choose to stop the server if it's crucial to have the audit record be unbroken. And in this case, it's a file path, but I can choose to go to the security log, or I can go to the NT application log as well. So all these things are possible. And in a similar manner, I can go ahead and look at the server audit specifications and its properties. I can do the same at the database level. So unfortunately, I've gone over time, but that is the last of the content. So My apologies for not leaving time for questions and answers. I'm happy to stay here as long as you need to answer questions. And tomorrow there is the SQL Server 2005 security best practices and 2 separate Wednesday and Thursday interactive sessions. I'd be happy to entertain questions there for SQL Server 2008. And please, if you can, I'd like to have your feedback, so please fill in the session feedback. Thank you.